parent function for absolute value that goes with 47 is this. Vertex here is 0, 0, because it's understood that those were the two. So in 47, when you look at that question, and 50, kind of, but more 47, this opens up still, so it's still a half, because that is bigger than my, or less than my 1 that we had. Okay, so that makes it, in this case, if we are looking at it, it makes it wider. The 1/2 should be that second one there, because we were looking at making it wider. So just the opposite. This is going to be where it's greater than 1 when the slope is greater than 1 or less than -1. And the parent function gets wider if it's going to be between 0 and 1. So those are our fractions. So this one gets wider. The vertex, instead of it being at 0, 0, and our parent function moves to 4, 7, because that's my x and y, and it opens upwards still. So the parent function is just like saying, what if it is just y equals x for linear, or y equals absolute value of x? How did it change using the slope and these? So that kind of goes back to the last one. Does that make sense? Okay. Anyone else for questions as we were looking at our parent function plot? All right. They say use the point 2001, 17.6, 2002. So if we're going to write our trend line, the first thing we need to do writing the trend line is we need our slope. So if I'm going to find the slope, what did you use in your numerator?
I did 18.75
Yep.
minus 17.6.
Minus 17.6. We're going to take 2002 then, minus 2001. So we get 1 in our denominator, right? And in our numerator, we get 1.15. So I'm starting to write my equation. Y equals 1.15x. It's positive. What does my y-intercept look like in this one? Someone said, well, it looks like 12. Is this 0, 0? Not if this is 2001, right? This is 1996, right? So we want to use one of those points and go to point slope form. So which point do we want to use? The 2001 or 2002? We just found our slope, 1.15x. Someone want to pick one for me? Which one am I using? 2001. So I'm going to have x minus 2001, that's my x coordinate, plus 17.6, correct? Get those calculators out, we're going to do some multiplying. So as we are distributing, we still have our slope, but now it's in slope slope-intercept form, and we get a negative 2,200 and what? 83.55. So this is the equation I want to use. Putting this as negative 2,283.55. Says, well, what about tickets in 2009? Is that my X or my Y? 2009. That should be X. So I'm going to go into this equation, and instead of X, I'm going to put in 2009. But this equation says, predict when the prices will be 40. Oh, 40 looks like it's way out there, right? It's like maybe now in terms of this graph, right? So this is when Y equals 40. And I'm still going to use my equation. It's just that this one I'm replacing X, and this one I'm replacing the Y. So this one would be like 40 equals 1.15 X plus a negative 2283. That make better sense? Okay. If they just say write an equation, you can stop right here. This is an equation. Stop at point slope. Don't make a mistake doing distributive property. stop there as we look at those, okay? So, yesterday we did recursive and explicit. I talked about that. That's in that video. We talked a little bit continuous and discrete. We talked about slope and what does it mean, that parent function, slope and y-intercept. Again, if you are still struggling with that, make sure you check with me. This page, 55 through 60, we talked about independent and dependent. Think about what you're doing in science with your independent and dependent variables also. And then we worked through 63. So as you guys are looking today, we are going to start at number 64. And are there any other questions prior to 64? Yeah. Yours is 64? Perfect. Good place to start. So, as we are looking at 64, some people are trying to make this such a harder problem. This is going back to the very beginning of the year, writing really super simple equations, okay? Really basic, like probably what you did last year in tree algebra. Very basic equations, okay? So we're looking at 64, and it says a gecko and iguanas are both lizards. The length of the average gecko is about, so gecko, I'm going to use G for gecko. Could I have used Y? Yes, okay? It says it is, translating is, that's my equal, about 3/5 the length of the iguana. Equals 3/5 of the length, 3/5 the length, that means times iguana. Oh, Mrs. Thompson, could I have used 3/5 x instead? Same thing, right? So I get the equation. I don't care which one of these two you use. That's what I'm looking for A. But then it says, well, if the gecko is about 6 inches long, so we know G is 6. So we know 6 equals, that's my gecko, 3/5 times the iguana. First off, should the iguana be longer or shorter than the gecko? So 3/5 of whatever this one is gives us this, right? So just to kind of think in our heads first. If this is 3/5 and I want a 1 here, I want to find what is the iguana. What could I multiply 3/5 times to get 1? I could use 2 numbers. I could do 2 operations, but by the reciprocal, 5/3, right? Oh, I forgot about reciprocals and solving equations. Yep. 5/3 multiplied by 5/3. 30 divided by 3. We thought it should be longer, right? It was. It's 10 inches. Or I heard someone said they thought it was longer. I'm not sure if I did it right. Well, 3/5 as a decimal is 0.6, right? Or take 3/5 times 10. Oh, I get 30 divided by 5. That's 6. Oh, that's what I was supposed to get. So you can check every equation when you're doing these, okay? So as you're looking at that one. Don't make it harder. This morning, you work 3 hours Friday, 6 Saturday. You receive an allowance of 20. Your totally earned is 92 for the week. What would be my first just basic equation?
92.
92, you like the number first, okay.
Equals 20.
Yep, get my allowance. Okay.
And
We don't know how much we're getting paid, right, per hour. So 3x and 6x. Okay. If I'm solving this, Larissa, we're going to add our like terms, right? I'm going to rewrite it and put my x's first, so I'd end up with what?
9x equals 20 minus 92.
So if we're going to solve this down here, 9x Still plus 20, right? Equals 92. What else are you going to do next?
And then subtract 20 from the side.
Subtract 20. 9x, Sophia, if we're solving it, 9x is equal to 72, and we get 8. You have to show me the right in here. No, I'm okay. X equals 8. The question doesn't say X equals 8. I need an answer, right? It was a story problem. So the question said, how much do you earn per dollars or per hour? So you're going to tell me $8 per hour. Okay? Really, none of our tests is multiple choice or Scantron or anything like that. We take it over 2 days. It's not. It's like a regular test. It's like a front and back and 1 or 2 pages that we're looking at. Right? So the last part that we really have is just solving equations. I think we're going to go through these. I'm going to kind of try and answer questions as we're looking at them. So if you do have questions and we can look at them, we're going to go through. So we're going to start with our distributed property. We're just going to keep working through them. Talking about the different options when you get to the absolute value. So Griffin, start me out. If I'm looking at number 66, tell me what to write down. Okay. Minus 20 plus 12g equals 1 minus g. All right. Riley, I'm going to continue solving that one. What are you going to do next? Add like terms. So I got 5g and positive 12, right? Negative 1. How much did you get? Okay. Allie, you ready? What are we going to do next? Adds g to both sides. So I get 18g minus 20 equals 1. Viola, what next? Most of these equations are going back to, like I would say, unit A. Add 20. So I add 20 to both sides. I get 18g is equal to 21. I'm solving it. Hayden, what am I going to have? What do you have to do next? You do. So if we divide both sides by 18, and I'm taking a look at that, what are you going to have? What did you end up with?
1.16.
G is equal to 1.16. Do both the 1 and 6 repeat?
No,
just a 6. Okay. Could I have left it as G is equal to simplify 21 over 18? Could I have left it as 21 over 18? I would take 21 over 18. Would I take 7 over 6? Dividing them both by 3. I'd take that also. Yeah. For sure. Let's do 72 and 73, and then we'll come back if we need to look at some of these other equations, okay? So 72 absolute value. Key thing, remember absolute value. Anytime you have absolute value, there are always 2 possible solutions. Okay? Always 2 possible solutions anytime we look at those. So the first thing you always have to do when I am looking at these absolute values is you must isolate your absolute value. That means get it all by itself. So the first thing I'm going to do is add 1 to both sides. Remember, you can have no solution. I have 4 times the absolute value of n equals 10. Next thing at this point, as I am taking a look at that one, I'm going to divide both sides by 4 because I need to isolate my absolute value.
It's 12.
Is this 12? Oh, I had 11. This is 12. Okay. Yeah. Okay. Good thing you're watching my addition here instead of me subtracting them. So, for absolute value of n equals 12, this is much nicer. You could have had 11 over 4, but this is nicer. Absolute value. So we're at this point, and we go, oh, absolute value of n equals 3. There are two possible solutions. The original, n equals 3, or the opposite. Because, and so maybe the activity we were going to do next week, we might do that one. It's a Desmos one, but it's all about absolute value and fraction and inequalities. So the other one is that n equals negative 3. Both of those are going to produce, if I say, how far is negative 3 from 3? It's 3 away. How far is 3 from 0? It's 3 away. So 73. First thing I'm going to do in 73, I have to isolate absolute value. So I divide by 2. And I get the absolute value of x plus 2/3 equals negative 1. And my first thought is, oh, I got to split it. There's two possible answers. But absolute value can never, 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 never equal a negative value. Oh, that's why it's no solution. If this is negative, x is equal to no solution. Absolute value can never be negative. So I'm going to stop before I get very far with that one. Yeah.
So if it was like a positive, then would you like continue by getting rid of the fraction?
So if it would have been positive, so let's say we had absolute value of x plus 2/3 equals 1. You would have had to do x plus 2/3 equals 1 and x plus 2/3 equals negative 1. And we would have subtracted 2/3 and said, oh, x equals 1/3. And we would have subtracted 2/3 here and said x equals negative 1. And I have these two answers. Okay? But since ours was negative, we stopped. Anyone have any other ones that you look at this page and you're just like, oh crap, I don't remember any of this. Yeah.
Like 75 and 67.
Okay.
73.
Same ones. Okay. We'll get through a few of these, and then you guys can kind of go back. And again, you're going to see most of these, the literal equations, those go all back to unit A, is when we did literal equations. So, here, we are asked to find for H. This is, just to be clear, A, that's like the area, is equal to 1/2 times H and times B. They just don't write those multiplications in there, right? They're assuming mathematically you know that. So, when I take a look at this, then how could I get rid of 1/2 and have it be 1 in front of that? What would I have to multiply by? 2/1. So I'm going to take this whole thing, I'm going to take this times 2, and I'm going to take this times 2. Because now I don't have a fraction anymore. So that's the first thing I like to eliminate. So I have 2a equals h times b. Well, it's h times b. So when I am taking a look at that, if I'm going h times b, Jacob, I want to find h. What's the opposite of multiplying by b, or inverse operation? Divide by b. Yeah, divide by b. H equals 2 times the area divided by b. So we did quite a few literal equations, and unit A is where you're going to find this. 77, I heard the other one, and I heard 76 too, but we'll look at 77 and let you guys try 76 and depending. Then we'll kind of maybe look at a couple of fraction ones, and we'll see where we're at. So 77. A equals b times x times t plus c, and we're solving for x. So the first thing I need to do is isolate the x. So Kaden, what would you do to isolate the x?
I would first
Subtract
subtract C.
c. A minus c equals b times x times t. Only thing I want to find is x. So Allie, what could I do to get this x by itself since it's times b and times c?
Divide by B.
Divide by b. Can I do it all in one? Because nothing simplifies for sure. I can do it all in one. So A minus C all over BT. Could someone else have written it this way? A over BT minus C. Yep. Same answers, just written differently. Okay. Okay, so I want to look at let's look at 67, and maybe we got a couple more on this side, and then we'll be able to look at them later, okay? So if we are looking at this one, start me out, Viola, in 67. We're distributing it, right? So 2R, then what? So minus 5, and then what did you say? Plus, minus, what am I doing? Oh, wait, I'm taking negative 1 times R. Are we right here and writing it, right? This is 2R out in front. We multiplied here. We got negative 5. Now I have to take negative 1 times back here. Plus R. Okay. On this side, I'm keeping everything the same. All right, Sonia, you ready? Can I add some like terms on this side?
Yeah, that would be 3R minus 5 equals 13 plus 2R.
Okay. Grace, what are you going to do next to solve?
I'm going to subtract the R from the right side.
So tell me what to actually write down.
2R minus 5 equals 13.
Wait, how'd you get 2R? Did you see that we got 3R here? You agree with that?
Yeah.
Minus 5 equals 13
Oh,
plus
what's
2R. Do what?
1R.
1. Okay, because you subtracted 2R from both sides. Okay.
Yeah.
Don't be afraid to show it on the test so you don't make a mistake like that and say 2R when it should have been R minus 5 equals 13. And Griffin, we're going to finish it off. Plus 5. R equals 18, right? I'm on the final. I have time. You want to check it. How do you check this? How do you make sure that you got the right answer for R? Because you finish the test and you're like, huh, I should just go back and check. What? Go up to the original and replace R with 18. And everywhere here, this side has to be equal to this side. And you can do it really simple and quick on your calculators. You take 13 plus 2 times 18 and get that answer, and then you plug in R over here. And every place where R is, you plug in 18 and do the multiplication and check it, okay? As we are looking at that next one, Sophia, you want to start us off at number 68?
Sure. 2A minus 8
Yep.
equals 4A minus 2A.
So we're adding our like terms as we are looking at this one. Riley, what are you going to get on the?
Oh, 2A minus 4.
Equals 2A minus 4. And at this thing, we're thinking, oh, that's one of those special ones. It's a no solution or it's infinitely many. But then what would you do to make sure that we get it right? And I'm going to subtract my A's. Always get rid of the variables first. So when we are looking at this, we get negative 8 equals negative 4, which then, no solution. If it would have come out true, negative 8 equals negative 8, we'd say all real numbers. Again, the question came up, Mrs. Thompson, you're going to mark it wrong if I say all real numbers or infinitely many, like on the, when you do solutions with or with your systems, those are going to be usually infinitely many. You put all real numbers. I'm not going to mark it wrong. Big picture, you guys are probably doing okay. You get it. You're understanding. That's the key thing for me. That you understood that there was kind of a lot of solutions versus no solution, okay? So that next one, it almost looks like it's the same, right? So you go with 4 minus D equals negative D plus 4. Make that 9, D. And if I add D to both sides, I get 4 equals 4. And I could say X equals all real numbers. Or you could tell me there's infinitely many solutions. Some of your math teachers going forward are going to be a lot more stickier on that than I am. I'm at the end of my career. If you get it that far, I'm pretty happy. If someone's going to care more next year, they'll tell you, okay? So we will start on problem 70 and 71, looking at those fraction ones. We don't have that much left. We'll kind of look at these. We'll go over here. You got a few more. These are all those literal equations. You got some absolute values again, but this time it's with inequalities. So just be really careful when you do those two splits that you have to take the opposite of both. You have to take the opposite. So one is going to look exactly the same. Everything is the same. The other one is the opposite of both the inequality and the number. Okay? And again,